Hi, today we'll continue our journey with a simple HTTP server implementation. Specifically, we'll implement Multipart File Upload, building on a few things that we have learned in the previous video. So, let's start. I will link down below the previous video because knowledge from that will came out handy. There we basically implemented a simple HTTP form where we were able to upload a few text files, subscribers specifically, but we didn't implement a file upload. That is what we'll do today to simplify and speed up the whole process. As usual, I have prepared a few things. So first is that I have made our simple HTTP server a little more configurable. For the most important things, I have changed its public API slightly, and I also changed logic where we parse body of the request so that if it's too large, if it is above certain threshold, described here as you can see, we read it to a file. And why we are doing that? Basically because multi-part file uploads that we are about to implement, they can be quite large and we shouldn't store them all in memory. So with this new config option, we have a simple condition that if file is not greater than the body as file threshold, we read it as previously to a memory, but in other case we read it to a temporary file that we have configurable with some random name. Because we care only about, we want to have access to a request body just for a while. To process further, we don't need to store it. And to do that, I have also changed HTTP request slightly. It can have right now it can have a body as by array of bytes or as a file. Previously it was just array of bytes. We also have a few utils around HTTP headers, and I think in the HTTP responses to make it easier to build responses basically. And if we go to the main class, one of the main classes, one of the two main classes that we will work with today, I have prepared a simple HTTP form. Let's maybe, or before checking it out, I will also show you what we are about to do, which is that, similar to the previous video, we'll upload forms. We have some errors. We're about to go there in a while, but if we upload, if a request is a form upload, we will have special handler here that we refer to the multipart form data reader that we're about to implement. It has lots of to-dos. I have prepared this structure and some util functions and data structures to make it faster, because as you will see, it's quite complex, this multi-part form data format. So let's maybe start and see what we already have. If I go to the browser, let's refresh it, we have a form like that. We'll be able to choose files and describe them. Both fields are required. And here we see uploads that we have made. If we upload without inputting anything, we have errors passed in the URL as in the previous video, but inputs are prepared. So I have also prepared a few files, as you can see. So you can choose, we'll work with text files, images, and even a video. Let's choose text file right now, some description. And we also have errors because it's not implemented, but we can check out what the multipart request look like. Unfortunately, if you choose a file, for some reason Chrome doesn't show it. So if we have only inputs without file chosen, we will see the payload more or less. So this is more or less what it looks like. This is a body of form, multipart form data format. So we have a boundary and we have parts. In our example, we have two parts, file and the description. And as you can also see, it is named like that. Here we have file, here we have description. Description is something that we have inputted, and we don't have anything for file because we didn't choose it. And there are headers, and each part is separated by this boundary. After boundary, we have headers, also separated in a similar way as in the exact same way as in the standard HTTP requests. So we have carriage return and a new line here. Here we have carriage return and two new lines, also the same as headers and body separation in the standard HTTP requests. And two parts, every part starts with boundary, and the last, the whole request, the whole body of the request is ended with boundary and two dashes. And this boundary is random, but chosen, maybe not random, but chosen by the client, because if you go to the headers, we will see that we have in the content type, we have multipart form data and the boundary. So that's how we know what it should be. Confusingly, this boundary is some value chosen by the client, but as you can see, we only have four dashes here, and in the payload there are 6, and that's how it is defined in the spec. Confusingly, to be honest. So this is what you have. This is what we need to work with. We need to parse that. Right now we don't. So let's go to our server and basically implement it. As I have said, I have prepared and shown the whole structure. So here, where we have an upload, we need to implement our algorithm to parse multipart form data requests. So here we have just a few sanity checks. We require content type header to be present. Same with the properly formatted boundary. In the content type header, we require content length. If not, we will not read the body. And here basically we read form, that reading of which we're about to implement. Here we have a few params, so let's maybe check them out. So we need to know how large the multipart form data, the whole body is, how much bytes we need to keep in memory. We are about to see what does it mean in a while, but more or less it's a threshold where we decide that body part should be kept in a file, because as I said, it can be quite large. We can send a few large files, for example, in one multipart from data request. We have a boundary because we need to know it to interpret the multipart from data. As I said, we have default content type if it's not present in the headers, and we have temporary files directory for parts that are larger than this. And threshold of files in memories of how much bytes we can store for each part in memory is defined here. We have 100 kilobytes. I also have set these two guys lower than necessarily on purpose to show that it will be triggered, and we'll have them in files. We have boundary from header. Text plain is our default content type, and here we have defined temporary files path. This is where our simple HTTP server will store temporary files. If you don't like it, or if it's not according to your files layout, you can obviously change it. Having said that, we can start implementing this read method. Maybe also another important thing is that we have input stream as a function here. This is because we will close and open it multiple times, and input stream is either array of bytes or a file, depending on the HTTP request specifics, basically. So let's start, guys. We have a few boundaries here that can get quite confusing, but unfortunately this is how it is defined in the spec. So we'll use dash boundary is this boundary that we have spoken about, where we add two dashes to the boundary that we got from the headers. In the headers, here we have a few sizes that will make our algorithm easier to implement. We don't need to go over all of them, but we basically need a few sizes of bytes between boundary and a first dashed and a few prefixes and postfixes. We will cover that while implementing. And this simple function is just turning string to ASCII to bytes in the ASCII encoding, because this is how headers are encoded. We have a few constants that we will use, and that's basically it. So what we need to do, we need to finish a few to-dos basically. Here we have first one, and then we have a few other ones in the appropriate places. So let's start. We'll cover them as we go. So first of all, we have multipart file prefix for files that will store multipart parts of the multipart request and its bodies. Here we have an assumption. We start. This is this counter of how many bytes we have read. We assume that we start with the boundary and then two dashes byte size we have here. Yeah, I think I have named it incorrectly, to be honest, because it shouldn't be two dashes. I mean, it can be, two dashes, but I would also say that we need to have yes, because here we have freeze boundary, and then these guys, so I would say 2, or maybe headers separator bytes size, and let's have it here, and let's do this. Yes, and header separator byte size. This is exactly what I meant. Between boundary, it is also that here as well. Maybe let's name it as this guy, but it need to be more to make it more readable. Let's say new line bytes or new line separator byte size. Maybe not have it convoluted with that guy. We can repeat it. It will not. I think it's clearer right now. Alright, so what we basically assume is that we skip that because we assume that it is in our input stream. So here what we need to do is, I think, something like that. While we have read less than params size, we are about to in each iteration we will open the input stream and read things from it. Here just Java things, but we don't read input stream from start. We will skip whatever amount of bytes we have read already. So on the first go we'll skip just the start of the whole multipart request. So this guy plus line separator, new line separator, which is carriage return, and new line feed or line feed, whatever it's called. So once we skip that, we can read part. So I would say part have read until method. Here we go with input stream. Max memory size we have from params. Temporary file. So let's create a part file, and its parent directory is also taken from params, and we will store it in this multipart file prefix. Plus, I would say let's add it part index here. Okay, so part file. What else do we have here? Let's see. Part file. Yeah, part 5, boundary prefix, and 2 postfixes. So let's maybe explain that. So where we have prefix between or last boundary prefix bytes. So basically, between parts, our separator is this guy, and last is this guy. It just has 2 dashes, and this guy did not, but he has character and new line separator. So their common prefix is this. They always start with new line separator. So we use that, and if we are between parts, we have this ending, so 2 character returns between boundary postfix, and if we have last, we have this guy. It also always has this new designs. Yeah, maybe they are not necessary, but they are there, so it doesn't hurt. Let's see. Right. So at this point we have parts, not yet because we didn't. We need to implement a few things underneath, but basically once we have a part, we have raw parts. It is a raw part. We need to parse it further. So let's maybe say that it is a raw part. It's added here, and once we have it, we need to say that we have read a certain amount of bytes. So something like that. Read plus part size, but we are going to take parts separator into consideration. So here we have one condition. So between parts, or maybe read boundary bytes, and here we know from this raw part record whether it was last, and if it was last, it ended with last boundary byte size. We have it here. Yes, this is correct because it ends with 2 dashes, and between we have that guy. He's between. So between boundary byte size, this between is slightly less than the last, as you can see. Yeah, and here we just need to add it. Yeah, and that's it for the main loop. We can maybe let's run it. It will not work, but let's see what happens. Right, some kind of exception. Yes, because we have a null somewhere. That's to be expected. So let's continue with our implementation. Right now, as we have this main loop, we read parts until we have expected size. We can go to read until method and also implement it. So here we have input stream of the single part, and we need to read it either into bytes array of bytes in memory or to a file. So here we have just some kind of packet, buffer, whatever, to temporarily store 100 kilobytes of data, and we have a condition as to whether store it into a file or in memory and when to end it. But basically we need to have a while loop, and while loop I would say is until read bytes are more than 0. First, let's have an index of what we have read. We're about to use it, and while index is less than read bytes, we will do something. First, we need to start, we need to check whether we actually have ended reading this file. So is pattern index. Let's check this guy out. I have implemented previously, but basically it just checks whether in bytes of this length, starting at this index, whether we have this pattern. That's all. Nothing fancy. So we'll use it to check whether we already are at the end of the part, keeping in mind that we have two cases: between parts, postfix, between parts, being between parts, and being at the end of them. So here we go with packet, in which we have a packet of bytes. We have read, this is how much we have read. An index is this guy, and here we need to check prefix. And if we are at it, we need to check these two cases. So first is pattern index again, but starting at here. So maybe let's have a variable prefix index. So basically something like that, and we check between whether we are here, and we'll write there something. But we also have a second case of being at the boundary last part, postfix, like that. And in both cases we are going to end our reading. So we have this method. Let's just copy it, and we go there in a while to explain what it does, but here we just need to return. But here the difference is that it is a last part if we are at this boundary. What this function / method does is basically checking whether if we have file output stream defined. We don't have it yet. It means that we were reading only from in memory, so that's why we have this variation. If we had it in file, we have file output stream, we write last bytes to the file, and then we return raw form part of file. The raw form part is basically a really simple data structure with either content bytes or content file, and informing us also whether it is a last or not. So yeah, keeping this in mind, we have these guys, and we only have implemented recognition that we are either at the end of one of the parts or of the last part. But if we are not, we need to continue reading. So in packet, we have bytes that we have read. We need to transfer them into this buffer. So basically, writing packet writing a single byte, and if buffer size is larger or equal to how we have named it, max memory size, that means that we should write it to a file because it's too large. So one more condition is that we have these variables, so we need to check whether it is null or not. And if it is, we set it to new file output stream. We have file. We need to also say that we should append to it, not override it, because we can write multiple times to it if part is large. Having that, we need to get it and write to it from what we already have in the buffer. So basically buffer to byte array, and it will take what we have written previously here from the buffer. Once we did that, we will reset it, if I remember correctly, and it will have size 0 again. And one more thing, we need to continuously do this, because we have read packet, and here we don't update how much we have read. So this is for one loop, for one read, and here we should read again. And if we will be at the end of reading, it will be either 0 or -1, and we basically end this loop. Yeah, so this is it. What we don't have, we can run it again. It will fail, maybe differently. Yeah, maybe differently, maybe the same. Yeah, because we don't have anything in the, but as you can see, we have body. Yeah, let's go back, not getting distracted too much. So where we were, we are implementing read until. So this will work, I think. And we can go on to this mapper. So this guy is taking raw form parts and converting them to a form part, which, as you can see, is a more higher level structure. It has parameters that we need. And this is what we need to get in the end. So where it starts, 2 form parts, we have a list. And this method is needed to be implemented. So yeah, one if of bytes, but we need to have these guys. Alright, so both index, these 3 guys we will get from the headers. Yeah, I don't have but we have example here. Yeah, so in each part we have things like that, attributes and some content type. So we need to get them. we have another method here. So let's go with it. So basically, let's start like that. Headers index, I think headers with both index, form part, content, stream. Yeah, throws exception. I think we should do it like this. They're throwing. Okay, let's drag. Stream. Yeah, and let's work here. So put stream. We have index. We have headers. Headers index. Yeah. So headers. It's a map, and body index is headers and headers index, body index. And let's see what we need to have here. So basically we need to get index of the body and read headers from this guy. So here we are from the input stream where we have only one part. We are reading n bytes. I assume that this limit of this is our headers size limit. And here we need to take this head into headers, and we are going to have body index. So let's start maybe with body index actually. So you can do this like that. Body index, we just take the header string and index of, it's that simple. Yes, it's just two header separators. Two headers separators, the same as in the HTTP standard HTTP requests, and we require to have it. So if it's like that, we throw an exception. Cannot find part body index. Something simple like that. So we have it, and right now we will just go with headers string and interpret it line by line. So it's split by header separator. Let's have key and value. So split by headers, standard headers separator, key value separator. So this guy. Yeah, this guy. And we can have at most two parts. One more thing. If it's empty, we ignore it. Yeah, or rather we end it, because if it's empty, it means that we don't have any more headers, because this empty case would be that we have gotten to this point, to body index. So we can maybe, if length is not 2, we can ignore that. In other case, we have key and value, and that's all I think we do here. So key, you can strip that, ignoring any any white spaces, as it is this guide here, trailing white spaces, and that should be it for body index and headers. So what we have here, name and a file name. But how we can get name and file name, guys? It is in the content disposition header. So for that, we have this method that we're about to implement. Let's see what it needs. So content disposition, content disposition data, and headers. I think from that we can just take it, yeah, to disposition, and the content type will be from headers. I think we have, yeah, constant here and default if it's not found. And I think it will be that basically. Can remove defaults from here, and we will need to implement this guy, because that's nice having this data from content disposition header, but first we need to implement it. So what we have here is that we require content disposition to be, let me just check something. When were we implementing this? Yeah, okay. Name and file name we need to get from content disposition header. At this point we know that we have it. It has this form. So this we ignore, but we need to split by semicolon. So let's do this. So I know parts, split it by this. We have a few parts, and each is a key value. Other than that, so let's say that parts split similarly as their attributes, at most 2, and if it's not 2, as in this example, in this case, we don't care. Then we have key. Basically, that's easy, but value can start with double quotes, and we want to ignore them basically. So let's do something like that. Value strip, but if value starts with this guy, let's trim it in the start, and similarly if value ends with this guy, let's also do this. So value length -1, and then we have key and value. Can also like not do anything with this value if it's not name or file name, but that's really an optimization. So I would say that if name is null and key equals a name, yeah, we will set name to value, and else if file name is null and key equals file name, not here, not also here, yeah, file name is value then. Yeah, and at this point we'll have it, we have content disposition, and basically last two things is to do something with this body index. So if raw form part is of bytes, not here, also not here, here we need to take body from memory. So basically we need to copy array of bytes. So that's really simple. From raw form part we take content bytes starting at this, and I think that's it. Let's check. Yeah, from to, so from body index, and we copy the whole array. That is the simple case, and in the other case we need to take it from a file. Yeah, so here we have a file, but we need to, it doesn't exist, we need to write to it. So first we need to take this guy as a content stream, and our output will be file output stream, this with this file that we have just created, throwing exception, let's move it here. And basically we need to transfer this input stream to this output stream, but also not at the start. We should skip bytes of this body index, and here quite handy, input stream already has this transfer to method. So I think that should be it, and it should work, because if I remember correctly, yeah, we don't have any to-dos, any remaining to-dos. So if we didn't make any mistakes, it should work. Let's see, guys. Let's go to the main page. Let's try to upload it, not doing anything. Doesn't work, so yeah. Now let's see what we have done. Content disposition is required. Alright, so something went wrong, guys. Let's see. Where we have made a mistake. Okay, sheet boundary bytes. I think these are just 2 bytes. That could be wrong. It shouldn't, but let's see. Yeah, that probably was not it. Yeah, between boundary byte size. That seems fine. Between boundary, between prefix. Here we update the guys, these guys. Let's maybe check whether we read anything at all. So read part, raw part. And let's see. Yeah, so we read something, but alright, so we are reading things, but they are not. So we are reading them, but somewhere in this headers are probably not parsed correctly. So I would say, let's check the headers. Checking headers out. Let's see what we have there. Upload. Ah, yes, we have them, so everything is fine, but uppercase, we have uppercase keys in headers, and as far as I remember, yeah, we assume that lowercase here, so for the sake of simplicity, let's do lowercase here. Let's see what will happen right now. Yeah, so we got something, but we require a description in the file. For some reason, the file is not required. Why? Let's see, guys. Yeah. So here we upload file form. Strange. Let's see how file size. I think we have a bug here. So typo, yeah, size is 4, but I didn't upload anything, guys. So clearly we made a mistake here. Yeah, so wait until alright, guys, I have fixed it. I've forgotten that body index. We need to add this bytes as well. Yeah, that's it. Maybe we can yeah, but I think that's good. Maybe we can have some kind of constant for it, but I think that's perfectly reasonable. So right now, if we try to upload something, as you can see, it is both fields are required properly. If I didn't add them here, and if we have a screenshot, we have as previously, but here, as you can see, if I go to my File Explorer properly, we have a nice multipart. Yeah. Yeah, with text files, it is in memory. So as you can see, we have some note, and we can also what else we can do? I can also show you how to, because that's body, that's the whole request. Let's maybe go to the terminal, simple, and we can less it. Yeah, yes, yeah, and as you can see, this is a raw part not body, but all of it. And we have the same things as we had in the network. We can also upload a video. It will, but this large file, this will take a few seconds, but let's see. It should pass on. Yeah, we have it. Yeah, this paths obviously they don't tell us anything, but we can see that we have something rather large here. Yeah, over 500 megabytes. It is video MP4. And if I go to File Explorer, as you can see, we have a video. Okay, something went wrong. Alright guys, I don't know, it's something that has to do with the permissions of my file system, because as you can see, it all shows proper valid properties here, and it has size is 527 and something megabytes, and we uploaded it from here, and the size is the same. So if I copy it here to my user folder,
hi guys,
it all works.
It's been a while, but I'm back.
Yeah, so it all works, guys. It was a lot of work, but we have implemented multi-part form upload, file upload from scratch. So that was quite interesting. So if you like the video, subscribe to the channel, and I see you in the next one. Cheers!